Right? Hyperbolas are the last conic section that we're going to look at. The ones we've looked at so far is x squared plus y squared equals r squared. And we said if you divide it by r squared, you get the familiar 1. What is it that we would do to make this an ellipse? Yeah, these are going to be different. You're going to get x squared over a squared is going to be different than b squared. If a is greater than b, it's going to be elongated around about the x-axis. If it's more vertically charged, then a is going to be under the y if it's about the y-axis. Skinnier about that. So elongation is going to tell you where to put the a squared and b squared. We'll see something similar here. So the only thing that we have to do to make this different is we're going to do the x squared a squared, we're going to do the y squared b squared, and we're going to do the 1. What's the little thing that's going to be different? Right there. Now, the reason that this is going to be different is this is when e was less than 1. What do you think this is going to be? E is greater than 1. And the reason it works this way is go back to this formula for b squared. B squared is equal to a squared 1 minus e squared. For an ellipse, if e is less than 1, this is what it looks like. E less than 1. But if e is greater than 1, what will this quantity be? If e is greater than 1, what will happen to the quantity? It'll be negative. And so what you're going to get is b squared is equal to a squared times a negative when you do 1 minus e squared. And so if b squared is negative, see how that negative is going to just make this minus. There, I just proved the hyperbola. How'd you like that? Never so fast. So one more time, if you're looking at a directrix and you have a focal point here, and you take the distance, we did an ellipse before. This distance from here to there, this distance we called, this was P and this was N. PF over PN was your E. Now if E was less than 1, this thing here, the PF was shorter than this one. So for a hyperbola, apparently what happens is that this thing makes this one shorter, right? So that PF is now greater than PN. And that's what changes it from being an ellipse to a hyperbola. And because it's a hyperbola, the shape isn't the only thing that changes. You're going to get something new here. You still have a directrix. You still have this directrix x equal to k. And it's still going to be x equal to a over e. It's still the same. Your focal point still is a, e, comma, 0. Still the same thing, and you can see it proven. It's still the same ratio, so it's still going to be the same thing. But what's different is that if you took x squared over a squared plus y squared over b squared equal to 1, okay? And let's say we moved this over to this side. So you get y squared over b squared equal to 1 minus x squared over b squared. I think this is neat. What happens to this 1 as you take the limit as x goes to infinity? What happens to this 1? It's nothing, right? Nothing happens to it. The 1 is, it becomes so irrelevant that we don't even need it. So then y squared over b squared is approximately the same as negative x squared over b squared, or a squared, I mean. And so then what you're going to get for a formula, I'm running out of space here, very much running out of space. Y over B is approximately equal to negative X over A. So Y is approximately negative B over A times X. This is what we call a diagonal asymptote, or more accurately, they call them the they call them. Oh, they got a nifty name, and I can't think of it. Should pause it. Well, they call them oblique asymptotes. Yeah, they just call them the asymptotes. So they're going to have a new characteristic here. You're going to have negative B over A is going to be X equal to Y plus or minus. These are going to be your asymptotes. They call them oblique asymptotes, but that's it. So we still have directrix, we still have the focal point, now we have these new things. And what's helpful about these is you draw these, you draw your vertex, you draw your focal point. You can just pretty well sketch those hyperbolas in between those little arms. Okay, so we still have a directrix, got to remember that. Okay, so when you look at the geometric properties, E is greater than 1, we talked about that. A is greater than 0, B is greater than 0. So if you have one of these situations, everything else is the same. Focus is AE, the directrix is A over E. You still have your vertex, your major, and there's no real minor axes, but there is this major axis. This is still A to here, and negative A to here. So that's all. And let's see, simple hyperbola, we got that. You've got those formulas. We just discussed it. Now, if you reverse it so that the hyperbola is vertically oriented, you switch the focal points, you switch the vertices, you switch the directrix. Now it's at Y equals, no big deal. And you switch the asymptotes. Those switch or no, those were A over B. No, those were B over A before, so now they're A over B. But everything else is the same. Okay? And then there is a distance property. PF minus PF prime is 2A. Instead of adding them this time, you're subtracting them to get 2A, and we'll be able to prove that a little bit later. All right, so let's take one and see what we can find from it. Sketch 4x squared minus 9y squared equals 36. So I'm just going to take 4x squared minus 9y squared equal to 36, and I'm going to divide by 36. And that's going to give me x squared over 9 and y squared over 4. So a squared is equal to 9. Therefore, a is equal to 3. You'll be able to find the focal point. Well, not yet, because we need to find e. B squared is going to be equal to 4. So, excuse me. So b squared equals a squared times 1 minus e squared. Let me double check that, because I think that's wrong. Yeah, it is. I need to switch that e squared minus 1. It was 1 minus e squared minus 1. Why do I need to do that? Aiden, can you help me out here? So this is e squared minus 1. Remember that we have the formula x squared over a squared minus y squared over b squared. So what that means is you need to embed this minus sign in here, and to do that, that's what reverses it. So would you write yourself a big note? This is the one thing you're going to mess up if you're going to forget something. This is reversed. This is reversed. from ellipse. We missed this last year, and I'm glad I did it this year. It's different for a hyperbola. Okay, so then b squared was 4, a squared was 9, e squared minus 1, 4 over 9 is equal to e squared minus 1. Look at this. E squared is equal to 9 over 9 plus 4 over 9 is 13 over 9. Does that make sense for a hyperbola? It's greater than 1, so we know we did it right. So e is the square root of 13 over 3, and e is greater than 0 for our drawings. Okay, so then everything else is the same. Focal points. You're going to have plus or minus a times e. So a is 3 times square root of 13 over 3, comma 0. Your directrix, that's going to be x is equal to a over e. So a is 3 over root of 13 over 3. So this is going to be 9 over root of 13. This is going to be plus or minus root of 13, comma 0. It's the focal point. X equal to 9 over root of 13 plus or minus, that's the directrix. We have one more thing we have to do, though, and that is you need to find the equation of the asymptotes. And that is going to be y equal to plus or minus b over a times x. So y is going to be equal to b was 4 and a was 3. So plus or minus 4 over 3x. That's it. That's it for a hyperbola.